Good evening everyone, welcome back. This is my third video and I hope you saw the other two videos that I made. If not, you can always check them out in my previous videos. In the first one, basically, I show how you can tame, yeah, how you can effortlessly tame and fix the thermal issues on your Alienware Area-51m, which was the first video. And in the last video I basically showed how you can squeeze the maximum performance out of your i7 or i9 CPU, and yeah, I recommend checking those videos out. However, in this video, and I believe it's the most anticipated of all of them, I'm going to talk about how we can overclock and undervolt the GPU so we can get the best maximum performance while keeping the thermals in check. So, a brief summary of what I'm going to talk about in this video is how to overclock and undervolt the GPU, how to set up the tool required, in this case is MSI Afterburner, how to create a quite balanced overclock and undervolt profile. So basically this is an overclock profile that we are going to use for balanced and quiet mode profiles for the fans, the ones that you can select from here, which might be useful for some people. Then we're going to look on how to create the best overclock and undervolt profile, for example for 4K, or if you want to use your laptop in VR, but this will require at least the performance, thermal profile, or even full speed profile. And lastly, we are going to look how we can bypass the thermal limit that's currently set by the BIOS at 79 or /80 degrees Celsius. So for the record, I am using the latest BIOS, which is 17.3 because 1.1 was removed, and we can see it here, 17.3. And on the GPU, I am running the latest vBIOS with a cap at 180 watts, as you can see there. So I'm running the i9 9900K and the RTX 2080 in this machine. So let's get started. First thing you're going to need, if you don't have it, is download MSI Afterburner. Yeah, I was looking for a skin there. And I would recommend going on guru3d.com and you just, yes, I accept the cookies. You scroll all the way down and you get to the latest stable. So that's, you install it, run it, and after you run it and you set up your on-screen display, we are going to enable a couple of things in it. And I'm going to run it right now. We are going to enable the voltage control. So in order to do that, you can either Google it and see another video, or you can follow the following steps. Go to settings, go to general. You need to click unlock voltage control, unlock voltage monitoring, and here you select from reference design or whatever is the default to third party, right? Yes, it wants to reboot. We can say yes, fine. However, that will not be sufficient. What you need to do is navigate to Program Files x86, search for MSI Afterburner, and then go in Profiles, and you will have two profiles. Those are the unique identifiers for the hardware. You will have two of them on this machine because one is the, I don't know if I can show it. One is the Intel chipset, the Iris HD 630 or whatever. Yeah, yeah, this one. And the other one is actually your discrete GPU, which is the RTX 2080. I don't know exactly which one is, but we're going to do the same thing for both of them. So you can open them with your favorite tool, Notepad or Visual Studio Code. And here you need to find the settings section, and you need to write this VDDC, which is voltage direct control, voltage direct control, generic detection equals 1 in the first one, and on the second one you need to do the same thing, VDDC generic detection equals 1. And after you do that, the settings in MSI Afterburner here, we just need to reset MSI Afterburner or restart, and then you will get the voltage control there. However, to appear in the OSD, you need to go to monitoring and scroll all the way down. Enable it by checking this check mark, or yeah, and then we are going to put it in the on-screen display or the OSD. And in my case, I put it in the same group as all the others. So, and then you don't need to restart the MSI Afterburner for the SD to kick in. So in the previous video, I showed you the normal, which the best performance / thermal profile, which at that point I called test, but now I renamed it to normal. You can rename it just by clicking. And that's basically capping the CPU in the green zone. That's 4.7 on the first two cores, down to 4.4 when all cores are used, with a voltage of 1.1 volts and an offset of 100 millivolts. And I'm going to use this profile for the CPU. And on the GPU side, we said we want a limit to 70-60 Celsius, and we want a mild overclock to 100 megahertz, and memory clock to 200 megahertz. And we apply this, and this is what it should be applied when you boot up your PC if you're using this profile. If not, I would recommend starting from here, or yeah. So back to MSI Afterburner. The first thing we're going to do is actually hit the reset button, so we get rid of the overclock from Alienware Command Center. And before we do anything, we open Google and we search for RTX 2080, in my case, specs. And we should get the specifications. We don't go there, we just go to NVIDIA and we look at the official and original specifications. Yeah, scroll past all that, and we get here. And it's interesting, view full specs, because we get the CUDA cores, the ops, gigaarrays, blah blah blah, boost clock. This is the thing that we're interested in. So the reference spec says the maximum boost clock is 1710 megahertz. The Founders Edition, which is a little bit overclocked, adds 90 megahertz, so it reaches 1800 megahertz. But we are looking at the reference spec here. So that's 1710. So, well, we have already done that, and we talked about that. So now the next thing we are going to do is how to create a quiet / balanced OC UV or overclock undervolt spec. So once you know your reference spec max boost, go here to MSI Afterburner, and you can either press something here, I don't know exactly what, but you can on your keyboard hit Control and F, is the classic combination of the find function or search. So Control F, and you should get the voltage frequency curve editor. Now you can use the OC scanner, but that's just a waste of time and I wouldn't recommend it. And you will get this graph. Now if you look closely, on the horizontal axis we have the voltage in millivolts. On the vertical axis we have the frequency in megahertz. This curve will be completely and exactly the same for every RTX machine. So it doesn't matter that it's an RTX in a desktop, it doesn't matter that it's an RTX in an Alienware, it will be completely the same because this comes from the driver, right? I don't know about the Max-Q form factor, yeah, it doesn't really matter in this case, but this will be the same for you as it is for me. So, with the 1710 megahertz maximum boost in mind, we are going here in the curve editor and we are going to see where that frequency is achieved. So is it there? That's 1785. Is it there? That's 1755. Is it there? 1725. So you can see at 1725, 1710. Oh, yeah. If you move something by mistake, you can always press Ctrl Z to undo. Right? So 1710 is actually at 0.850 volts or 850 millivolts. Now, why is this thing important? I'm going to show it. Before we do anything, I'm going to show it. So I'm going to run Metro Exodus for this demo. The reason I'm using this game is because this game really loves to hammer your GPU. So it's a very GPU intensive game. CPU doesn't really matter in this game, but it will eat your GPU up. So let's wait for it to boot. So currently I don't have any overclock applied. I just have the standard curve as you saw it, and there at the top we see that we have currently we are running at 40 degrees, and yeah, decided to do something funky there. In the meantime, I'm just going to say I don't want any sound from that. Yeah, so we are running at 50, going up. Our boost is currently at 1860. We are pulling 1 volt, actually close to 1 volt there, 0.96 950 962 millivolts or volts, and our frame rate is 90-ish, 90 something. For the record, I'm running full HD, ultra preset, ray tracing on ultra, everything absolutely maxed. And we can see it's boosting to around 1800 and it's pulling 0.9 something millivolts or volts in this case, right? We're already in the 56 degrees power temperature limit, as you can see. And now the clock will go down and down and down and down and down, right? While maintaining roughly 90. So we're going to alt tab off from that. And we're going back to the curve editor. And we said that the official spec says the maximum boost is 1710. So if you look at 1710, which is here, come on, there. This clock can be achieved at 0.850 volts, nowhere near 1 volt that's currently pushing or pulling in this case, right? Obviously the boost will be 100 megahertz bigger, but the voltage is also 0.1 volts higher, more than 0.1 volts higher, as you can see. And we are in the power limit because obviously currently we are drawing more than one or close to 180 watts. So what we want to do is, once we find 1710 here, select this tiny little dot square or node, I'm going to call it node, and press on your keyboard the L key and you'll get this yellow bar. And then go to MSI Afterburner and hit the apply button. This will basically lock your GPU to run at the clock you specified, in this case a little bit lower, and at the voltage you specified. As you can see, 850 millivolts, and we get a boost clock of 1695. So we want a little bit better than that, so let's go on that one, and we get 1710 at 856. Let's go back in game, and in game we see exactly the same thing. We are pulling 0.85 millivolts, but our boost is 1695. Okay, so you obviously don't like, because you can see the red line is actually on the previous node, not the current one. So let's bump this one up a little bit. and see if you are actually going to stick to the node we want. So right now we are at 1710 and we're pulling 0.862 volts. And as you can see, as a result, our frame rates suffered a little bit, I guess. 1 frame, 2 frames, 3, 4 frames. Yeah, I still hit 90, so it's roughly the same. But let's see how this thing is going to thermally. So as you can see, we are not in the 75. We are hovering between 72 73. We are now at 73 stable. Our clock went a little bit down. I don't know if you hear it, probably not. My fans, because I'm on balance mode, starting to ramp up a little bit, but now I'm back on 72 degrees. So on this profile, just doing this, it appears that we are maybe, yeah, our performance may be degraded by a couple of frames. Hardly, yeah, very hard to say. But we are nowhere near the 75, 76 thermal limit that we put in our profile. We have the same frame rate. We draw obviously less current and obviously less power because we are currently not in any limit, right? So our clock is a little bit close to the reference, but it's a little bit down. So let's see if we can't increase that even a little bit more. So let's say I want on that one, lock L, apply 1725. So I want you to stay on 1710, which is exactly the clock maximum boost of the reference design. So yeah, as you can see, now we are pulling 0.868 volts at 1710 megahertz. Our temperature is 72, 73. We are on balance profile. My fan is not ramping up. Now it's ramping up. It's 75. Now it's probably to the maximum RPM the balance mode allows. We are definitely pulling a lot more current, as you can see. Not current, sorry, voltage. And my temperature is trying to go down. So just by increasing the voltage with a couple of millivolts, so from 0.85 to 0.868, our temperature went up by 2 degrees, while our frame rate is basically identical. So, and in frequency, we just bumped 15 megahertz. So the question is, do these 15 megahertz matter? Now, I can tell you right off the bat, they don't. But our temperature does, right? We are still not thermal throttling, so that's good. But yeah, that's not the best scenario, right? So I can Alt Tab and I can go back to the previous node like we were before. Press L to lock it, apply, go back to game, and let's see if we can repeat the same test. So yeah, we're at 1695, 15 megahertz less than the spec, but we are drawing 0.856 instead of 0.862 or 65. So those 10 millivolts, they make a huge difference in thermals, as you can see. So we are in the 72, nowhere near the 75. So we just saved 3 degrees and maybe lost 1 frame, or let's say 1 frame per second, something like that. 73 degrees. So 2 degrees Celsius difference. Huh? No, keeps going up. So maybe we didn't save anything. Let's see. This is the long test. So, but yeah, 74, maybe 1 degree. So, yeah, now the fan on the GPU is at full capacity based on the balance profile. So, yeah, our performance, as you can see, it's 87, 89, 90. It's all over the place. So, yeah, we can definitely say that we saved 1 Celsius for 15 megahertz, right? So, yeah, I'm going to stick with this value or this node, right? So, I like this node, right? So, if you remember, so this is just finding what is the maximum voltage that we can supply to the card at what boost clock based on the reference design that will make the card not overheat, right? So currently we just find, oh, this at 0.862, it's the voltage that we need to supply the card, and the card will not hit the 75-76 thermal limit that we imposed, while maintaining very close to the reference design boost clock, right? So we found the node. And if you remember in the first video, I actually said, oh, let's overclock the GPU to 100, put the thermal limit to 76, and memory to 100, right? But because now we are using MSI Afterburner, we are overriding this. However, now comes the overclock. So I say, okay, we found what this looks like. So what I want now is to apply my overclock of 100. Let's apply 100 and say apply, and 200 on my memory, right? And using the same voltage, now instead of being at 1710-ish, we are at 1800. So let's go back to game. And inside the game, we see we are pulling the same current and voltage like before, right? But our boost clock now it's at 1785. As you can see, our frame rate, it's gone up 93, 94, 90. So the minimum now is 90, and the maximum is 94, while before it was 86, and the maximum was 90. So as you can see, as a result, we are a couple of frames higher. However, we are very close to thermal limiting ourselves. So let's see what happens. We are 74, 75 there. My fan now started at to run at maximum fan speed. The maximum RPM of the balance profile, I mean. Oh, and now we're going back down. So we are hovering there. So just applying that 100 megahertz, we basically are using the same current, same voltage, and we are maintaining the same temperature. We have a nice around 100 megahertz boost, and we gained around 4 or 5 frames per second, yeah, something like that. But the fan is currently running at max speed. So the next thing I can do is, because I'm talking about the quiet balance OC UV, it's like, okay, we apply the overclock both on the core and the memory. For the record, increasing the frequency on the memory will make your card rise a couple of degrees in temperature based on the amount of frequency you increase by. So we said that we applied overclock. We found from standard where the point of the best current or voltages for the reference design boost clock, and we applied the 100 megahertz overclock. So now I'm going to find, actually, let's see. Nope. If I go there. So actually now I can, with this 100 megahertz overclock, I can maintain the reference speed at a much lower voltage. So let's do that. And as you can see, we are at 1725, but now I'm pulling only 0.818 volts. So let's go back in game. As a result, we should still be in the 85 something. Yeah, maximum 90, 91 even, 93 even, 94. Ooh. But our temperature should be much lower, nowhere near 75. And as you can see, we are significantly pulling less voltage. My fans went down, of course. They will ramp up at some point. So 1710. We are exactly at the reference speed. And our FPS, it's a little bit, it's still kind of the same. Hard to tell in this game. Yep, we are still not at full speed, 73. Now we're at full speed. Will it go back to 72 or will it stay? Yes, yeah, it tries to. Yeah, 72. 72 degrees. 1710 reference spec boost clock. And we are using and gaining, or getting the same FPS roughly. Obviously, compared to the other boost, we are losing around 4 FPS. Yeah, you can see it's hovering 86, 87, 88, 90. While before the minimum was 90 and the maximum was 94. So yes, 3-4 FPS. But our maximum temperature is currently at 72. If you're happy with this, you can just unlock, save it as a profile. I'm going to save it on 2, right? However, if you want to push it even more, you can push it even more. Let's say I want a little bit more because I still have a couple of degrees more that I can go. So let's push 1755, right? Let's see what happens at 1755. So 1755, let's see the temperature. Obviously, this will maybe increase the absolute minimum frame rate a little bit, but it does increase a little bit, maybe by 1 frame or 2 frames. It's hard to tell, but we are interested in the temperature. So 72, the fans start ramping up again. We are at 1740, 73. Come on, fans, go to maximum speed. Come on, 74. Fans are now at maximum speed unbalanced. Will it go down to 73? Yes, it will go down to 73. So we increased by 30 megahertz and we gain 1 degree Celsius because of the 0.80, because of the increasing voltage. So, but basically this is the concept of how you overclock an undervolt, or how you undervolt and overclock in the same time, right? But I'm happy with this profile. You can tweak it. You can spend much more time on this, which I'm not going to show in this video because basically it's just doing the same thing over and over and over and over and over again, right? So but I like it. We are not hitting any thermal throttle. We have very good FPS, very good current. I mean, the CPU is like, So this is, for the record, only on the balance profile, right? You can Alt Tab and go here and wherever it is. And let's try quiet. Why not? Let's try quiet. Actually, let's wait for this thing to start updating. Come on, come on, come on, yeah, right. So let's go on quiet mode and see what happens. Probably on quiet mode we'll hit the 75 degree thermal limit, which is imposed by the profile, and then we will hover around there. But let's see. 72, 3, 4, 5, 4, 5, 5, 4, 5, 5. Temperature limit. My fans now are ramping up to the maximum of the quiet profile, and as you can see my frequency is hovering between 1650, 60, 50, somewhere around there, 80, 50. My FPS has been degraded by 1 frame, 2 frames, 3 frames. Yeah, maybe 1 frame, because I saw an 85 there, which previously I didn't see. But as you can see, yeah, a couple of frames, let's say, a couple of frames. But this is on the quiet profile, right? So you could play Metro Exodus on the quiet profile with this overclock and undervolt, right? As you can see, the current now it's 0.7, definitely way lower. Now this frequency, for the record, on the stock profile, you will not be able to get this frequency on this voltage. But yeah, the quiet profile for this game, which stresses the CPU, the GPU, as you can see, is not recommended. So I would recommend balanced for this game. However, even with the clock going down, you can see the frame rate is not really affected that much. So maybe if you are, I don't know, in a library where you're supposed to be very quiet and you want to play a game, you can put it on the quiet profile with something like this, and you can still play with a very good FPS, no thermal throttling, putting your clock to whatever, no loudness. I think this is something for that. So yeah, as you can see. So because my fan speeds are maximum at 60, so but this is how you could do the balanced and quiet profiles, right? So back to Afterburner. So after you found out that yeah, I want 100 megahertz and 200 on the memory, and we found that yeah, we could push 1750, 1710 niche at 0.831 volts because we tested it. Now comes the part where we actually finalize the profile. And in order to finalize the profile, what we need to do is to select every point and put it to the same frequency. So 1755, right? 1755, 1755, and you can do this for every single point. However, if there are multiple points, I'm going to show you a shortcut. So the maximum voltage an RTX card can draw, according to the specs, stops at 100 or 1100 millivolts. So it can't pull more than 1.1 volts, which is exactly here. And as you can see, from here all the way to the end is basically a straight line. So the shortcut is you go here with your mouse, you hold and keep pressing shift, you click and you drag and you mark this area, and then you select on the first node, and using the down key you keep on lowering this until you get to the same line of 1755, right? And you get something like this. Now the moment you hit apply, Come on. First, I need to unlock this. Because technically, the moment I hit apply, it doesn't want to. Okay, we need to do more. Normally, the moment you hit apply, the curve should level. But maybe it doesn't because we are outside of the supported spec. Right? Okay, so let's add more. I'm going to select those three. I'm going to lower those three to 1755. Right? Going to those three. I'm going to put those 55. Going to put those to 55. What if I do that? Ah, still didn't want to. Okay, so we'll have to do it the hard way. Okay, so this is our one. That's a little bit awkward because it used to work like that before. Maybe I'm doing it wrong or something. Actually, I think I'm doing it wrong. If I do that, yes, and select the last one. So I select all these points from the curve. Then I go to the last node and I put the whole curve down to 1755. 755. And now I hit apply. It will level it. Yes. Now I do the same thing for this. I put it to 1755 and hit apply. Now it will level it. So this is the shortcut that not a lot of people are aware. This is how you quickly level a curve. Right? What does this mean? We're going back to this node and we are going to unlock it. What does this mean? This means that once the card reaches this point at 0.825 millivolts and reaches the 1755, when it wants to go to the next node to reach more power, to draw, more current, more voltage, it says, oh, at the next node where I'm supposed to use 0.831 voltage, my boost clock is actually the same. What about the next one? And the next one? Oh, all of them are the same. So my maximum frequency is actually 1755. So there is no point in going to draw more voltage for this clock when I can actually stick on the first one. And I'm going to hit apply. And I hit apply. As you can see, our GPU is not loaded. We are back to 750, somewhere there, as you can see based on that red line. I'm drawing 606 millivolts, which is somewhere around here, I guess. But once we go back to the game, we see we are drawing 1755 at 0.831. It's exactly what we specified on the curve. And you'll see that it will not go above the 1755, 1740, and it will not draw more current and voltage, right? Because like I was talking yesterday, current multiplied by the resistance of the circuit will give you the voltage, right? So the resistance could change, not the physical one, but the resistance of the circuit will change with the temperature. The current will be the same. So, and if the resistance grows because the temperature grows, the only thing you can control to keep the same voltage is to lower the current. But yeah, so we're 72. 90. Now my fans are at the maximum speed on balanced, 71. And there you have it. 90 frames per second and 91 Celsius. at a stock clock with a very low voltage. So this is how you overclock and undervolt, right? That's Metro Exodus for you. Fully playable, 90 frames per second, full RTX, RTX Ultra, not even high, which everyone uses. Okay, so yeah, balance mode 71 degrees for balance mode, right? So next thing I would recommend is to press the save button, put it on a profile, and apply it at startup, right? Apply it at startup, and yeah, I would log that so you don't accidentally save it. Which means that every time you boot your Alienware, this curve will be applied. And that's because MSI Afterburner burner is smart enough to override the profile, the GPU profile that the Alienware command center applies. So yeah, unlike the CPU, the GPU works perfectly fine. So that's that part, and which we talked about that. Now for the performance, it's basically the same thing. What we want to do, I'm going to show you quickly for 4K VR or VR. First thing, you want to go here, you want to say, okay, I'm going to put this on performance mode. Yeah, I'm not going to try full speed because, yeah. But yeah, let's say performance mode. Then we go here, we Control F again, and we want to say, now here's the thing. Here, what you need to do is to, without a curve, just see what's the maximum clock you can add to your GPU. Doesn't matter if it's thermal throttling, doesn't really matter. What you need here is to use something like 3D Mark, right? 3D Mark doesn't have enough time to completely burn your GPU, so it hits the hard throttle, right? So use something like that and find if your GPU can go all the way to 150. I don't think it can. 150 will be fine in Metro Exodus, will be fine in Wolfenstein, I think, but for example in Control, if you happen to have it, you will get a lot of device hangs or device removed or so on, because Control is very heavily on the RT cores and very heavily on the Tensor cores, especially if you're using DLSS, right? Wolfenstein Youngblood is not so heavy on the GPU, so you might get away with it, but it's very balanced. The load is very balanced between the CPU and the GPU, so there you see a bigger load on the CPU side, which can spike all the way to 100% usage, while the GPU is around 90-ish%. So experiment with this and find what clock you want to set up. So let's say you think 150 is fine. I'm going to use this one because I want to show you something later, right? 150 is fine. Okay. So you say, okay, from the standard curve, you say, okay, 150. We apply 150. Actually, before we do that, let's go back to our curve. And we said that we found out that for the normal profile, we want to use a voltage of 0.831, right? 0.831. Okay, cool. So we apply 150. Okay, fine. We find the 0.831 node, which is that one, right? So that's 101.830, right? And I have a profile selected here, and yeah, so 150. Sorry, 150. So we used 0.831. Which was this one. So at 0.831 we only get 1830, right? So if you log this one like before, and we go back into a game. This is on performance fans. We load it and let's see what happens. So basically we want to see, because the fans now are pushing hard and loud, we want to see what's the maximum temperature we can get. In this case, we want to see what's the maximum frequency we can get before we thermal limit. So as you can see, at this voltage and this frequency, our GPU is hardly increasing in temperature. So obviously we want more voltage and higher clock, right? So let's go and say, okay, what about this one? Not that one. Let's go about this one. Oh, let's go at 1950. I want 1950. I like 1950, right? But that's 0.9 volts. Well, let's try it. 0.9 volts. So, wow, that's an overclock over the reference spec of 215 megahertz and 135 over the Founders Edition. Awesome. Let's see. So boosting to 1935, you can see our frame rate. Ooh, maximum now is 97. I like that. I really do. So that's almost 7 frames per second max over the reference design, right? Our temperature keeps on going high, but we are now at 1920 while maintaining 0900 volts. So that's okay, I guess. Let's see. How far can it get? 69. 70. This is on performance mode. Will we get the 75? Though. 76 where we cut the current. 72, 71, 72 keeps going up. But now we're at 1905 and our voltage is lower. We're still getting very good FPS, but 73. I want more than 1905. I definitely want more. So yeah, let's go on that one. 1980. Let's see. Oh, for a second there, I don't know if you noticed. Yeah, power limit. So it means that we are drawing too much current and too much voltage, and the vBIOS is limiting. So basically, we are drawing too much, and this is not worth it. We are trying to draw too much current for this clock, and the vBIOS is limiting. So what we need is to dial down. L to lock, apply. What about now? Are you drawing too much? No, now you're not drawing too much. So I don't see the thermal limit. The power limit. I'm still seeing the power limit. So yeah, more than 0912 as you saw is too much. So yeah, 0912, as you can see, it's trying to power limit. So definitely once you hit the power limit, you temperature, that's fine, and now it's going down. So we are trying to draw too much. What about a node down? Let's use 0935. 0935. So we are still using the 0912, 096 voltage at 0920. That's, for the record, 210 megahertz over the reference clock, or maximum reference maximum turbo boost. We are still hitting the power a little bit, and now we're in the temperature. So yes, which means that first thing I'm going to do is actually no, I'm going to keep it on performance. Yeah. So fine. Apparently our profile doesn't allow us to go higher than this. But even at this voltage we are hitting the power limit. So I guess this is the maximum we can push this card. If we try to increase the voltage, we need to increase the power draw, which is controlled by the vBIOS. Obviously, you can flash an older vBIOS, but I wouldn't recommend it. The 1.003, which is a 200 watts cap, will actually allow you 20 watts more, but yeah, you'll not get a lot of more performance for the heat it generates, but you can try it. So yeah, let's say we like this point, right? So 150. So now we're going to do exactly the same thing like before. We're going to drag all this stuff and we're going to click here and put it on 1935. Come on. 1935, right? And we're going to hit apply. So come on, 1935. You can do it. Yeah, there we go. We can remove the lock there, and we apply it and go back to the game. 1950, 35. We get some, yeah, 97, 97, yeah, 96, 97. So we got around 5 FPS more. I mean, the absolute maximum is 92 compared to 80, 84, 86. So this is right, almost 10 FPS over. So 1920. The temperature will go up, sadly. But that's besides the point of this video. As you can see, it will not draw more than 0912 and 09, and the clock will not go at 0920, above 0920. Now for the reference, the curve that I have saved is this one, as you can see, right? And actually apply an overclock of 132 at 0.9. So in my case, I found out that 1920 at 0.9 volts, it's actually better than 0935 that I had before. I can't undo that, unfortunately. Yeah, at 0912, right? So here you need to experiment. After you've done that, obviously you can increase the memory more than 200. 500 is perfectly fine on the RTX machines. I have zero problems with it. So yeah, but let's say for example that you made your overclock like I showed you at 150, and suddenly you play Control or another game and your display driver starts crashing. You get like Battlefield or Control, and you get a lot of DXGI device hang or DXGI this or DXGI that, and your game completely crashes, and obviously it's due to the overclock, because if you're running without the overclock, everything's fine, right? So you can do the same thing again, basically finding the point that was in the previous overclock, applying instead of applying 150, try to apply whatever, find a point, and then do this and try again, right? You can do that. But for example, if you already have a curve that you know that it works in most games but doesn't work in some games, and you just want to lower the whole curve a couple of megahertz down, or you want to increase it for some reason, there's a very easy way to do it. You click on a node, you press Alt on your keyboard, and then you drag it. And as you can see, you can drag it wherever you want. Plus 500, minus 300, minus 1000, right? So this is how you quickly tune it. Once you have a curve, for example, like this one, and I want to put it at 150, you can slowly increase it to 150, hit apply, and now you have it at 150. As you can see, 51, whatever, 1 megahertz, 2 megahertz, it's nothing, right? So this is, yeah, as you can see, 1950 at 09 volts. So I wouldn't recommend going beyond 0.9 volts if you want to keep the thermals in check, and this is even on full power mode. But yeah, experiment and maybe you find something else that I found, but that's, yeah, my recommendation. So now, because we are on 151, and sorry, I didn't mean to do that. Let's put it up. Let's put it back to 1, 5, 2. Fine, whatever. And we are on performance mode. Ooh, nice. 195. I want it. I'm waiting for the CPU to overheat, basically. The GPU, not the CPU. The GPU to overheat to reach the 75 Celsius, at which point it will thermal limit, right? And you remember we hit the thermal limit, so we don't get into the 80, 79, 80 degrees thermal limit, which basically puts your clock down to 300, 500 megahertz, and your FPS basically goes to half. And yeah, nothing is playable. But as you can see, I'm still struggling to reach that value while I'm having 100 frames per second. Which is actually better than the one that I showed. Yeah, this is the profile that I fine-tuned. So as you can see, 1935, 0.9. But now I bumped it to 150. But for some reason, like I said, in some games it doesn't work, so I had to lower it to 132. But we are going to reach the 75. At which point we are going to hit the thermal limit. Come on. Yeah. And now my clock will go down. And I will lose a couple of FPS or whatever, but yeah. Okay. So how can we bypass that? Well, obviously I can put the thermal limit here. Sorry. Here to 79. So to avoid the hard thermal total, actually let's put it 1 degree lower, 78. Right? And you would think this is fine. Well, it's not fine, because you get in the thermal limit at 78, and then the game wants more power for some reason, or wants more GPU compute, and your GPU will push more power, at which point your temperature will suddenly spike to 80. The moment it suddenly spikes to 80, you can't even see it. The BIOS says, uh-oh, we're in the red zone. I'm going to downclock the hell out of it. And even for that 1 millisecond of the spike, if it bypasses the hard threshold, your GPU will go clockwise all the way down to 300 megahertz. We don't want that. However, what I do want is to go home. No, I want to go into Fusion, and I'm going to click on normal, and I'm going to say duplicate, right? So maximum temperature, unlimited power, basically, right? I'm going to go on this. I'm going to say, you know something, I'm a big boy, I know how to handle myself. So 87, don't care. 87. Yeah, I need to wait for this test, which doesn't seem to do anything anyway. 87, 87, 87, 87, come on. And the next thing I'm going to show, which is the last thing, we already showed that, right? Is how to bypass the thermal limit that the BIOS imposes. Going to save this. I'm going to apply it. So now our maximum thermal limit is 87, which means we are not going to apply the soft limit unless we reach 87. However, the BIOS will cut out us at 80, right? Which is basically the default. So we want to bypass that. So in order to bypass that, you go here on Google and you search for hardware info 64. And you go here. You can download the installer or the portable. I have the installer. You have it installed, and then you run hardware info. You select sensors only, but before you hit run, you go to the settings, and under safety, you go here, and this one will be enabled by default. You want to disable access to the embedded controller, right? Then you hit OK, then you hit run, and you get some warning about some EC controller not being monitored or whatever, and can say disable, which is basically the Alienware onboard controller, which is here. See, the EC Alienware Area-51, which this is the embedded controller that basically controls the temperature or measures the temperature. And when it sees that your GPU reaches 80 degrees, it would say, oh, I'm going to cut power for you. So we don't want that, right? We are not going to monitor that one. And because we are not monitoring, you'll see that the fan speed, this thing, is active. And you can click on it. And you can see that our fans currently are running at 2800 RPM, 3000 for the... before we do that, you want to go and say set custom. And for sensor 1, you need to find your CPU. In my case, it's the i9900K, and you want enhanced. And once you find the enhanced, select the CPU package, right? And if you want to, by default, there will be some numbers here, I don't know, and it will say, oh, you can only enter a value between 0 and 3000. So you say, fine, I'm going to put 3000 in all of them. It doesn't matter about that, because what I'm going to show you doesn't take this into account. Obviously, you can do it if you want your custom thingy, but yeah. And you hit OK, and then you go and say set custom auto. Find your GPU, which is the NVIDIA RTX 2080 or RTX 2070, 60, and you find the GPU sensor, which is the only one, and again, you do the same thing. And then here you'll say that, okay, well, I'm on system auto, right? It's active, but it's on system auto. So what you want to do is say, click again on system auto, becomes inactive. Your fans will completely cut out. Then you want to go play with this slider a little bit until you get the maximum value and say set manual. And set manual. At which point both your fans will run into the speed that's maximum here. Now the maximum RPM, which I'm going to show you in a second, from here, it's actually controlled by this profile, right? And for the sake of this test, I'm going to apply my curve, and I'm going to select quiet mode, right? Just to show you. Okay, so we're back here. We put the fans. Let's say system auto, we close that, play that, it's active. We say system auto, we play with the slider a little bit. We say, oh, 1000, maximum is 250, set manual, maximum is 2300, set manual. CPU, GPU, right? And now you should hear both fans, both the CPU first and the GPU secondly, start and running at 2500 RPM. Right, and now I have my fully overclock here, which is the performance one with 500 and 130-ish with overclock and undervolt, and I'm going back here. So my temperature now should ramp up pretty fast because I'm drawing quite a lot of current and having quite a big boost. It's not too bad. Oh, the GPU power overlay actually comes from hardware info. I'm going to show you quickly. If you go to settings, you can go to OSD, RTS, and here somewhere in the list you will find the GPU power draw, which, let's see if I can spot it. It is here somewhere. There, GPU power, show value, show label, right? The moment you click that and you have MSI and OSD from Riva tuner running and you go into a game, you'll see the power draw as well. So that's basically how you can know, that's how you know how much your GPU is drawing. Right, let's speed this thing a little. So I want, okay, I'll go there, up. I want 151, like I said. Right, come on, speed up. As you can see, because the G-Sync overlay, you can see it here in the corner, but I have G-Sync working as well, so come on. '17, '71. This is the patience game. Obviously, the thermal efficiency in the laptop is pretty good, because even in quiet mode, running this overclock and the undervolt, obviously, it still takes time to ramp up the temperature. But we are at 77. Will we thermal throttle at 7980 or not? We are hitting the limit power. We are 79. As you can see, it wants to draw more than 180 and can't. 80 degrees. Ooh, ooh, ooh. 80, 180. No thermal limit. 81. We are close to 1900. Very close. But we are limited by power now. 82. And then it will keep on climbing up in this profile. 83. Obviously now the clock will go down because of the power. It wants more power for that the proposed clock, but because the temperature keeps on going up, it can't. 85. And we will probably thermal throttle at 87 because that's the new limit. Obviously we don't want that, right? But however, keep in mind that I'm running on quiet profile, right? So if we go on performance, let's wait for the fans to kick in. We go back here. We say we close that. We go back here. We say system auto. Find me the maximum value 3000. Set manual. System auto. Find me the maximum 2200. Right. So as you can see, the fans. You can actually read the percentage of the fans here while controlling them from hardware info, which is quite interesting. And now we go back and you will see that the maximum in performance mode, the maximum temperature I get is around 81, maybe 82 degrees, but normally 81, and in full fan mode it's 79. So yeah, Temperature will still go up a little bit, but yeah, I'm going to leave it for just wait and see, I guess, that I'm not bluffing or lying. Before we reached 85, so will we reach 85 now or not? We're limited by the vBIOS and the power. 78. Yeah, it will go down a little bit. Yeah, for the record, 1890 is still 90 megahertz above the Founders Editions cards, which their maximum boost was 1800. So 79. And I think it will stabilize at around 81 or 82 in this game. This game is very heavy on the GPU, so, and I'm running in performance, not full mode. But you see, it cools, then it wants to boost to 1905, then it heats and it's limited by power because it wants to draw more power, so it's going down a little bit. Then it cools, it goes higher again, then it overheats, it goes down again, overheats, the power limit is kicked in, then it cools and so on, and you'll get that ping pong until it's actually stable. So 81, 82, I saw an 82 there. But you see it's kicking between 81 and 82, so I think in this game it's 82. So yeah, this is on performance, and you see the voltage goes up, down, and this is the ping pong that I keep saying about, right? That's why they added a new vBIOS instead of the 201. Now if you run the 201, you'll get the same thing at around 85 degrees, and you'll get the same clocks, same frame rate, only your GPU will be 2, 3, 4 degrees higher on this profile. So in this game I don't really recommend running this game on with this overclock. If you want 100 frames per second or close to 100 frames per second on performance file mode, I would recommend going on full file mode. But yeah, 83, so yeah, even a little bit higher than the 82 I said. But yeah, 10 frames gain equals, well, a lot of temperature gain as well. So yeah, there's a point when you start overclocking after which you require a lot more power to gain significant FPS improvements, and every watt counts in the temperature. It's actually going higher to 84 now. So let's put this one in full speed. Trying to close that. Yeah, close that. Maximum speed. Both CPU and GPU fans are on maximum. Let's go back to game. Yeah, but this is basically the idea. So this is how you play and this is how you make it, and I'm going to, yeah, this video is getting really long by now, but yeah. Anyway, I hope you enjoyed this video. and I hope it was really helpful and you understand how you overclock and undervolt in the same time, and how you can create your custom curve, voltage, temperature curve, voltage, frequency curve, and how you can tame the temperatures in this machine. And this doesn't apply only to the Alienware, this actually applies to every PC out there. So even a desktop that's air cooled or even water cooled, if you want to keep the thermals in check or whatever. So, but basically this is how you overclock and undervolt. So like I'm showing here, yeah, 150 megahertz I think is too much for this GPU in general, and yeah, this game likes to stress the GPU, so it should be stable around 79, 80ish maybe on full fan speed. So in any case, this is it for this video. I plan to make a new video, the last video, in which I'm going to benchmark, let's call benchmark, or show a couple of games, Metro Exodus included, in which I'm going to show you the default or the recommended clocks for the CPU and the temperatures, which you can already see. So I'm running 4.4 at 50ish, but my load is very small in this game. There are other games where the load is higher, so like Battlefield 5 or Assassin's Creed Odyssey or even Wolfenstein Youngblood, which likes to use both the CPU and the GPU. So yeah, I plan to make a new video which I go through a bunch of games where I show the CPU at 4.4, the green zone mode, then I show and the GPU at 1710, which is the reference boost clock. Then I'll go into through the same games with full fan mode and the tweaked CPU at 4.7 on all cores, with a bigger undervolt and PL1 and PL2 fixes that I showed in the previous video. And this GPU overclock, the proper one that I have and I'm showing to the same games. So we can compare both temperature wise, fan speed wise, obviously noise, and frame rate gain. So you can see that sometimes keeping your fans on quiet or performance and losing like 5 frames per second is maybe better than putting full blast mode and gaining 5-10 frames with higher thermals, or yeah, significantly higher degrees. However, this application, for example, or this mode has applicability if you go to 4K and enable DLSS as well. And yeah, so in 4K you can see there, in this mode I get 44 frames per second, and yeah, so that's 4K full RTX mode on the Alienware 51m. So yeah, if I lower the ray tracing from insane ultra to high, I will probably get 50, so a couple 6 frames more. But yeah, for if you want to play in 4K or VR, you want the best of it, at which point you need to sacrifice some thermal performance and some fan acoustic for better FPS, I guess. So yeah, so I really hope you enjoyed this video, guys, and it showed you and you understand how you can overclock and undervolt your GPU, how you can bypass your the BIOS thermal lock or hard thermal throttle. I was still on performance. Was I? Interesting. I think I was on full. Anyway, how you can bypass the thermal limit on the GPU side using hardware info, and how you can create your custom profiles, like I showed. How you can create your custom profiles. How you can quickly make the curve. So if you want something like you select whatever you want, you do that, and that didn't work. Come on. Well, not always, yeah, but yeah. So yeah, until next time, thank you very much, and if you have any questions, please let me know. See you on the next one. Thank you. Cheers. Bye.